Moving on to question 2. What would be the sequence for boron and nitrogen in terms of increasing effective nuclear charge, Zeph, at n equals 2? Okay, so let's define what ZF means. So this is the effective nuclear charge. So, in other words, this is the net positive charge that is felt by an electron. So this is mainly because the nucleus is positively charged. So depending on where an electron is, like how close it is to the nucleus of an atom, it will feel a different nuclear charge than another electron. So that is ZF. If we were to have just Z, this is the actual nuclear charge. And I'll also define S, which is the number of shielding electrons. Okay, so the reason I wrote down all of these different definitions is because we'll be looking at how to calculate the effective nuclear charge. So it's simply the equation ZF is equal to Z minus S. So if we know the actual nuclear charge and we know the number of shielding electrons, then we can calculate ZF. So in the question n equals 2, so let me just write here, when n equals 2, the number of shielding electrons is also equal to 2. So S is also equal to 2 since it still just corresponds to the 1s electrons. Okay, so let's pretend we had like an atom. And then those are our 2 electrons. Okay, so basically we just need to look at all of the other Z nuclear charge values of fluorine, lithium, beryllium, boron, and nitrogen. So this depends on the number of protons that are in that element. And to find the number of protons, that is just the same as its atomic number. So starting with fluorine, it has an atomic number of 9. And then I'm just going to do its S is 2. So 9 minus 2 is 7. And then let's do the same for lithium. It has 3 protons minus 2, which is 1. And then for beryllium, its atomic number is 4. So its effective nuclear charge is 3. And then for boron, it is 5 minus 2, which is, oh, why did I say 4 minus 2 is 3? 4 minus 2 is 2. 5 minus 2 is 3. And then lastly, for nitrogen, it is 7 minus 2, which is 5. Okay, so now in terms of increasing nuclear charge, we can rank all of the different atoms. So starting with lithium as the lowest effective nuclear charge, and then beryllium, boron, nitrogen, and then fluorine. Okay, so this is because fluorine has the most number of protons, and when n equals 2, there's not much shielding, so that electron can feel that net positive charge. Okay, so the junior tutor said the actual nuclear charge, Z, is the net positive charge experienced by an electron in a multi-electron atom. In general, if an electron is further away from the nucleus, more atoms will be in between that electron and the nucleus. The electrons in between will cancel the positive charge of the nucleus and will thereby decrease the interaction between the nucleus and electron further away. As the electron is further away from the nucleus, it experiences an effective nuclear charge, which is less than the actual nuclear charge. This is called the shielding effect. If the distance r of an electron from the nucleus reaches to infinity, the effective nuclear charge will be equal to 1. If the distance r of an electron from the nucleus is 0, which means that the electron is very close to the nucleus, and no other electrons will cause shielding effect, the effective nuclear charge is equal to the actual nuclear charge. Okay, so they have the formula Zeph equals Z minus S. For our question, we are asked to rank the given elements based on increasing effective nuclear charge. Since we defined that we want the effective nuclear charge at n equals 2, the value of S, which is the number of shielding electrons, will be equal to 2, since we know that the first shell always contains only 2 electrons. Z would be the actual net charges of each element, which is equal to its atomic number. And then computing for the individual Zeph of each element, we'll have 7, 1, 2, 3, and 5. Therefore, our final sequence in terms of increasing effective nuclear charge would be lithium, beryllium, boron, nitrogen, and fluorine. Yep, so this solution is correct. Okay, so on to question.